So today's speakers are leaders in public policy, transportation, technology, and research. Together, they offer a complete picture of the changing landscape of our transportation network, and in fact, of the very fabric of our communities. You've heard that over and over. Life in the 21st century will change for the better in the coming years, thanks to the work of all visionaries with us here today. And thank you to all of you. As the Executive Director of the Contra Costa Transportation Authority, I'm privileged to be able to help my region tackle some pretty big challenges. You have housing, congestion, affordable housing, air quality. All these issues are starting to bring transportation into the fold, and it's a challenge. 5 years ago, my board had the vision and foresight to understand that by moving forward with Momentum Station, CCTA would be entering into uncharted territory for a public agency. Today, Momentum Station has become a world-class proving grounds that attracts researchers, automotive manufacturers, and technology companies. In just 5 years, thanks to Momentum Station, we have become known for being more than a county across the bay from San Francisco. Momentum Station was formerly designated as one of the only 10 test beds in the United States and has developed a global reputation for being at the forefront of innovation, bringing self-driving vehicle technology to market. And that, my friends, is going to change the world. And I wanted to thank the City of Concord. We haven't mentioned the City of Concord, but once again, that base sits in the City of Concord, and we needed their approval, their partnership. So Mayor Carlin Obringer is here. There you are. Yeah, thank you for that. So sit back and enjoy the panels we have brought to you together for you to hear today from international perspectives on bringing self-driving vehicles to market, to designing cities of the future, changes in the way we get to the goods we use every day, to protect our data and passengers in autonomous vehicles. Today is about one more thing, redefining mobility. So before I welcome our first panel today, there are a few housekeeping items I want to get out of the way. First, if you have not already, please go to the App Store and download the app. I forgot what it's called now, Expo Pass? Yeah, okay, so download that. I did it last night, so if I can do it, you can do it. And also, if you're posting on social media today, please use the conference hashtag RMS 2019, and be sure to follow @CCTA for live tweeting from this event. We tweet quite a bit. Restrooms are located in the vestibules behind, over on the left of the auditorium, my left, not yours. And so now what we're going to do is we're going to bring an international panel up one at a time, and then when we're done with the four speakers, then we'll have a panel. Think of your questions, and then if you don't have any questions, I'll ask some dumb questions. So we have four panels, and let's see here. Andre Aparicio, the manager of advanced driver assistance at Atlas Idiata. Rita Excel, my friend from Australia, she's the executive director of Australia and New Zealand Driverless Vehicle Innovation Initiative. Naohiko Kakimi, the counselor for SIP ADAS, CAO and Director of ITS and Automated Driving Promotion Office at the Ministry of Economy, Trade, and Industry, otherwise known as METI. And Divi Camboj, the Project Manager of the Connected and Autonomous Vehicle Program at Invest Ottawa. So their bios are in the app, under speakers. So our first speaker is Andres. Andres, please come on up. Welcome.
Thank you. So, yeah, you hear me. Good. Thank you. Thank you very much for allowing me to be here today. We're starting this panel on our perspective of how testing for connected and automated vehicles can advance the deployment of them. I'm coming from A+ Idiada. We are a service company that mainly work for car manufacturers and suppliers, and we support them to develop their vehicles. We support them with engineering services and testing services. So we thought that it was quite nice for us to have the opportunity of talking about what is the testing environment in Europe and well, how this can support the deployment of automated vehicles. Okay? So let me start for an introduction, and it's good because we don't have had so many technical talkings yet, with a little bit about what do we mean for ADAS and automated driving that is currently in the market, okay? So if we try to make a timeline about how the systems have evolved, probably we can say that the first ADAS system started with ACC back in '92, first ESP controls in 1995, LDVs 2001, emergency braking 2003. So at that time, there was already some technology of some sensors able to detect the environment, and these vehicles were able to help to semi-automate driving in a highway environment, to keep the vehicle in the lane, or to brake to avoid accidents. But these vehicles were quite niche. Most of the vehicles here were for domestic market applications in Japan. They were not so popular, not so reliable, so there has more things to come. We can go later. 2008, that was the time where a car manufacturer in Sweden decided to make AEB standard in the vehicles. No extra payment, you get the sensors standard in the vehicle, and they ramp up. And 4 years later, they made it standard, able to detect pedestrians. And a few years later, able to detect cyclists. So really, technology was evolving. By that time, 2009, Google project starting, that is really something that we will see later for automated driving. But if we keep on vehicles that we already have in the market, probably now more familiar with the SAE levels, we have a vehicle that can semi-automate you in the highway driving, so both throttle, braking, and steering control in 2003, a level 2 highway, and in 2015, a vehicle that was able to park with the driver outside the vehicle, okay? And we think that in 2017, we will have, we were expecting to have, or we had the technology to have, the first vehicle that allowed the driver to step out of the driving task for some time, and he could text, watch emails, use the navigation screen, and so on. So this is the technology that has been evolved so far. And testing has been more or less accompanying this technology. My problem is that, for example, if we take stability control back in 1995, it did not become a standard and a requirement with a test procedure up to 2008. There's a big difference between the moment we have the technology and the moment we have a standard procedure and a requirement for the technology. So these are things that maybe we have to change. And if we compare what happened in the past with what was happening, Google started the project in 2009, and in 2011, United States had already a way of being able to deploy testing on public roads. So these timings, we have to take them into account, okay? So what are the challenges for automated driving? I think we have, of course, technical challenges. Vehicles need to be able to detect the environment, to take decision. I think at software and hardware level, architectures are going to change. Cars are going to stop being an embedded computing thing into a more PC architecture. So this is going to change. And of course, all these technical challenges need to be supported by validation. How are we going to test this and be sure that it's reliable? Of course, there are legal challenges. Product safety, we need to change the traffic law. Germany has changed the traffic law from a European perspective for that. And of course, if there is an accident, we need to have clear indications about who is liable for what has happened. Is the driver? Is the virtual driver? Is the car manufacturer? The road operator? So this has to be clear. And the third challenge is societal. Everybody here is very engaged about new technology, but automation will have to deal with acceptance, to balance driver expectations. Maybe we are over-expecting the performance of the systems. We will have problems with the transition phase, the moment that the driver the car is being in automatic mode and shifts into manual mode. That will be a big problem. And of course, we will have to deal with the first fatalities, because maybe they will happen. And if they are not treated correctly, maybe we will have problems for the later deployment. So I truly believe that testing and validation can be a very good enabler for this. With testing, we can ensure that technology is well deployed. With testing, we can ensure that we have a legal coverage, that there is a minimum requirement that is fulfilled. And with testing, maybe if we make public testing, we show that what the systems can do, we can get positive user awareness. So we truly believe that testing is a positive thing. So where are we from a European perspective? There is a lot of research ongoing at European level, both in all the world. And to give some classification about what kind of testings we can do, we can start with virtual testing, simulation. That means you don't need anything, you just need a virtual environment. You could go to an environment where you have a driving simulator, like a video game. You have real drivers, because typically the driver is the unpredictable subject. But you can have a virtual vehicle and a virtual test track. Then a controlled environment, test track testing. And I think this will be one of the major topics for the conference today, and I will focus my presentation on this later. So in a controlled environment, you can have a real driver or a virtual driver for the vehicle, a real vehicle, and then you create an environment that represents the world. And in the last moment, you have a field operational test, meaning that you drive on the public road. What I would like to say, and what we believe from a European perspective, is that all these 4 categories are needed, and they bring different benefits at different levels. So even if we will focus on maybe test track testing, because it's nice, you can drive the vehicles till the limit, we need to do not forget all the levels, and we will have to use them during the whole development cycle. The development cycle can be very complex. We will start from a concept. We will do traffic simulations. We will do software simulations, hardware simulations, testing the test tracks, go to public roads, and have real traffic. But at the end, we are very interested on knowing what we have to evaluate. We need to understand which scenarios. What are we going to test? What are we going to request to the drivers? And there will be a process where prototype vehicles will drive on public roads, and we will get data, I'm looking at the red arrows, how to generate these scenarios. And once we have these scenarios, we will be able to feed them to the early development phases of the projects. Okay? And from a European perspective, there are a lot of efforts to create these databases of scenarios. Then, going into more details, what kinds of testing do we have in Europe? We have regulatory testing. This is mandatory, like equivalent to federal motor vehicle standards, safety standards from NHTSA. So we have regulations for emergency braking systems. They became mandatory in 2003 for heavy-duty vehicles. Heavy-duty in Europe means more than 3.5 tons. I think we have a bias here when compared to US. Lane departure warning systems, a system that warns you if you are departing the lanes, also became mandatory for heavy-duty vehicles in 2013. And there has been a lot of work ongoing for automated control of steering functions, so the systems that will help you to keep in the lane, that will help you to not crash with a car that is on your side of your vehicle, and this was in place in 2018. And more is coming, especially applying to passenger vehicles, so not only for heavy vehicles, for passenger vehicles, up to us from 2020. So this is the regulatory framework. Of course, we have consumer testing equivalent to NHTSA US NCAP. So different NCAPs in the world, US NCAP, China NCAP, Japan NCAP, include some ADAS testing. From a European perspective, we have Euro NCAP. Australia NCAP is mimicking Euro NCAP. I think we have one of the most complete programs. Okay? We have procedures for vehicle detection, pedestrian detection, cyclist detection, lane detection, and speed limit information. Okay? And this is already in place. And thanks to these programs, 70% of the new vehicle models in Europe include a radar or a camera. And this is not mandatory. It's just because there is a website that explains the users what the vehicles are able to do. So this is having a very positive effect. And of course, in the next years, we will be facing a lot of challenges. Europe is concerned about powered two-wheelers, and there will be procedures for that, intersections, including roundabouts in Europe, oncoming traffic, emergency steering. So all this will be part of the program. Those were safety functions. Europe is also thinking on programs for automated driving. So how to explain to the consumer what a Tesla Autopilot is able to do, what a Nissan ProPilot is able to do. So Euro NCAP is in a learning phase for that. We have some proposals for system performance. It's very important to have an HMI expert assessment. It's not that important what the system is able to do. It's very important what the user expects from the system. And information has to be delivered correctly. So there are a number of information ongoing, tests that are already defined, and at the end, we are not that worried about the performance of the test. It's more that the user in the car really has the correct expectation of that system at that time. Okay? So how is testing implemented? And I think in the next sessions there will be more details about this. We have the tools. We are testing vehicles that have radars, that have cameras. They are interacting with balloon cars that move. They are interacting with pedestrians, with bicycles. Sometimes we include robots for driving. I will show you one video. This is a view of our test track. We are doing Euro NCAP testing. Okay? So it's a vehicle approaching a balloon car. The vehicle will brake to avoid the accident. I'm not going to show any crash. Don't worry. I'm only showing good results of the vehicles. But see, you see, we are in a very clean environment, very good asphalt conditions, and this is the phase where we are. We are still not able to test in complex environments, or systems are not ready to be tested in extreme scenarios. Only good results, don't worry. Okay. So, well, this is already possible, and I think we will get more details later. Okay? Yeah. So, on top of proving ground testing, which I think is one of the most interesting ones, I would like to highlight that virtual testing is going to be very important. We are not going to be able to test everything that a vehicle can do. Imagine the amount of scenarios that a normal driver faces every day. We are not going to be able to test them. So virtual will help to do that. And it's not only about how to have the simulation in a computer. It will be how we maybe are able to integrate a real driver with a computer, because at the end in a vehicle they might interact, how we integrate ECUs and so on. So this will be one of the very important phases. And the other one will be public road testing. This is already possible in the United States. It's also possible in Europe. And well, at some point, it will not be only about just letting the car drive. We will need to have some support from the infrastructure, maybe roadside units, some monitoring, and so on. Okay? So as a summary, what I would like to say is that from a European perspective, we would like to have a complete understanding about all the tools available. And Europe is in the way of generating the process of combining test track testing, virtual testing, and public road testing together. Okay? And this is it from my side. Thank you very much for your time. It was a pleasure.
Great job.
Thank you.
Okay, Rita, I think you're next. Let me see. Nope. Yeah, you're next. Come on up. And I failed to mention, so IDIADA's test bed is in Barcelona, Spain, in Barcelona, yeah? Mm-hmm. Yeah. Rita, her office and her testing is going on based out of Sydney, Australia, correct?
Yeah. Thank you. Thanks. Did I have a clicker? Clicker. Hello, everyone. I've got a couple of videos. I hope they're going to work. So thank you very much to Randy and Contra Costa Transportation Authority. Really thrilled to be here. My role is probably the best role in the world. I'm an ambassador for Australia and New Zealand about telling you what we're doing in Australia and New Zealand and finding out what you're doing over here. So thanks very much for the opportunity. So 2015, we came together. The host organisation of ADVI, which is the organisation I work for, is the Australian Road Research Board. So that's like the TRB equivalent if you're from the UK, TRL. So it's an independent research organisation and it services road agencies. We went to them in 2014 and we said, hey, automated vehicles are coming, we're not prepared. And they said, oh no, we'll just wait to see what America does. We can't predict what's going to happen. So of course we didn't take no for an answer and we said, right, we'll go and talk to some industry. And so we talked to industry. So we got some industry together, we got some active states together, and we're all joined by this vision. So it's not about letting this technology come organically to Australia and New Zealand, it's about accelerating it. And this is part of the acceleration journey. So we've got 130 partners. We started in 2015 with about 25, and now we've got 130. This is an older slide, and we've got a few new partners from a few days ago. If your organisation's not on this slide, you need to come and speak to me today. It's really important because what it is connecting researchers, industry, technology, a lot of startups, but also regulators. And it's important to connect regulators because they haven't got all the answers, but neither have we. But the only way we're going to get forward is to do this together and collaborate. So this is my little hero shot. This is what's happening in Australia. We don't list out exactly what's happening because it changes so rapidly. The icons show how much activity is going on in Australia and New Zealand. And what it shows you is that every state and territory in Australia is involved in this. And New Zealand, as a small country, is actively involved in this space. They've got a very proactive program. So it's really important that some of the use cases we've got in Australia can translate some of the technology being developed in the US and Europe. but also some of the unique use cases we've got that are being developed just for Australian conditions. We talk about kangaroos. I went to Momentum, there's cows, We have lots of large animals on the side of the road. How do these vehicles deal with that sort of interaction? But how do humans deal with that? And I think to the point of the previous speakers about simulation, understanding how humans react now and how the technology will react. So that's what's happening. And it's really important to understand that there's such an active market in Australia. So this is a little bit of a video, I hope, just to show you what sort of innovation's happening. So in New South Wales, they developed, they're building a metro, and it's going to be driverless. That's a big political statement to make. Rio Tinto, one of our bigger mining companies, developed their driverless train. Obviously, they've been developing it for a while, but they launched it. This is something that's really popular in Australia at the moment. Everybody likes the idea or notion of a trackless tram. Isn't it just a big bus? So these are things that there's a lot of interest in Australia about. We're also really fascinated by shuttles. I think the reason, I know you've got some at Momentum, lots of people are, this is something that people could purchase and play around with. So it's a really good starting point and an entry point. We've probably got some of the major manufacturers of shuttles operating in Australia. We've got two companies, one from the UK and one from France, that have actually set up a head office in Australia. That was one of my roles, to try and get them to understand the market and also the leverage into what we call in Australia the Indo-Pacific region. So it's about selling globally in some use cases they developed for Australia. So this is a little bit of some of the, most of our test beds are either in university campuses or on public roads. Some of these vehicles you'd be familiar with, some of the brands on there. So we run a conference every year. We've got our postal system that's been delivering parcels. They got a lot of bad press about delivering the parcels around whose job they were getting rid of. And so I don't know what happens here, but people get a parcel delivered and then they're not home. You have to go to the post office to pick it up. I work long hours. The post office doesn't service my needs, so they have to deliver a few times one parcel. So that was their intention. This is another little a shuttle that we put into a development precinct. A developer came to us and said, oh, well, we want to do this and show our community we don't need to build a multi-deck car park. So they just picked up their shuttle and brought it there for a demo. So, and this is our longest running shuttle demonstration. It's run by the Motoring Club in Western Australia. They wanted to help their community and their members, that million members, wanting to get them to understand what autonomous vehicles were all about. So they put one on a public road. They did a lot of work around that. So this is one of our RDM, has been based in South Australia since 2016 after the ITS World Congress. So we are really attracting industries and to Australia. But it's not just about the technology. I mean, we're all, into the technology, but the community, and I think we're going to hear that spoken about a lot. If the community doesn't accept this, then it's not going to happen. We had the politicians, and it's great to see so many of them here, but they listen to what the community says. So in ADVI, we run a survey. We do the largest scientific survey in Australia and New Zealand. It's a scientifically survey, and it's representative of the population. And what that tells us about 46% of people already think this is safe, but there's lots of concerns. So we thought, well, let's validate that. Let's validate that on the streets. So here's some of the feedback.
I've heard of them.
At the moment, probably technology is not quite up with the reality of the situation.
They're as good as what they say. It should be a good thing.
20 years from now, we'll have most of our vehicles on the road will be driverless.
I have heard of the concept. Sounds fantastic.
Driverless trucks. Dangerous. No good.
Bit too dangerous.
Large vehicle, small roads.
If it was proven with the trial runs and everything to be very effective and safe, I'd be happy with it.
In a metropolitan area, no, I couldn't imagine. Out in a mining facility, absolutely.
I would not feel very comfortable. I'd probably go no, I'd be hesitant.
No, not yet. We have to have the infrastructure in place.
That's a good question, would I?
I'd be very excited to give it a go and see what it feels like to be driven by a computer.
Jump in and have a look? Yeah, jump in. I wouldn't. I don't trust them.
Obviously, there are going to be some teething problems, but the algorithms associated with it, I'm told, are fabulous.
Not sure how I feel about it. I quite like having the ability to drive.
I think it could transform society in unbelievable ways.
There's always problems and bugs to iron out. Once the bugs are ironed out, usually it's all pretty good.
Humans get fatigued, they lose concentration. If this works well, it's all good with me.
Driverless vehicles would be pretty cool, but very unpredictable and I reckon dangerous.
Great idea, but I'm not sure.
So I've spent about 25 years working in road safety, and when young male drivers say that it's not safe and they don't trust it, I mean, we don't trust them and we insure them out of the marketplace. So that sort of just tells us, we did that about 1.5 years ago, and it just gave us a path with the statistics and the survey we've done, some of that consumer feedback. We sort of know what are the easy pathways to get this technology in place and what are going to be more difficult challenges. So it gives you a bit of an understanding of where the customer is at. So, everybody wants to know what's the economy, what's happening. So I showed you my slide of about 130 partners, and we wanted, when we go and visit the politicians in Canberra, we wanted to tell them what these actual companies are investing. And this is sort of the investment profile of what's happening in Australia and New Zealand. So, obviously it's not trillions of dollars, but it's significant investment, and this is, all the partners responding to the survey of what they were planning to invest. And I mentioned about attracting industries to Australia, and so there's a number of programs that are run through our Tourism and Trade and Investment Commission around attracting businesses to Australia. But one of the things I think, having met Randy a few years ago and seeing how Momentum's changed and some of the other test beds, I think the real opportunity is to learn from all the testing that's going on. So on this side, we've got all the activity that's happening in Australia. There's a lot of, in New Zealand. We could say it's competition, but I think it's just opportunities. And on the other side is what we understand is going on globally. And so we see ADVI's role is really connecting those things together and being that conduit between lessons learned and sharing those lessons learned. And this is a perfect plug for our conference, which is happening in October this year, so after the ITS World Congress in Singapore. So I'd love to see you there. Thank you.
Does anybody here know where I met Rita? No, not Barcelona. I met her on a rainy day in France in an Easy Mile shuttle. She was on one end of the shuttle and I was on the other, and it's been a match made in heaven ever since. So thank you very much for coming today. Our next speaker is from Japan, Naohiko Kakimi. Kakimi-san is flown out, and he wants to tell you a little bit about what's going on in Japan. He has a mandate to deliver autonomous driving by the Olympics in 2020 in Tokyo, correct? Come on in. Thank you.
Good morning, ladies and gentlemen. My name is Naohiko Kakimi from METI, Government of Japan. Thank you for coming for my presentation. I'm very happy to here in Redefining Mobility Summit 2019. Before starting my presentation, I have to introduce myself, my assignment at the METI, Director for ITS and Automated Driving Promoting Office, which is my title, is responsible for accelerating automated driving in Japan. I hold another assignment, Counselor for SIP ADAS. Cabinet Office is responsible for coordinating relevant agencies and ministries for new SIP ADAS projects. Today, I'd like to talk about automated driving in Japan. Introduction, SIP ADAS, especially FOTs in Tokyo waterfront city area, last mile mobility test by METI, especially Ehage Town case, and FOT for autonomous taxi in Japan. What are the driving forces for automated driving in Japan? Firstly, to realize a safe and smooth road traffic society. Second is to create a new mobility service. Third is to revitalize regional community and economy. Fourth is to strengthen international competitiveness of the auto industry. To deploy automated driving vehicle, it is necessary to work on technical development and legal system development, and to simultaneously proceed with supporting business operators to carry out social implementation and improving social acceptance by deepening the nation's understanding of automated driving. Government of Japan conduct cross-ministerial strategic innovation promotion program, SIP. Today I will explain automated driving for universal service. First phase of SIP ADAS from 2014 to 2018, and second phase of SIP ADAS is 2018 to 2022. This slide shows field of R&D about SIP ADAS. There are a lot of research areas about automated driving, such as recognition, prediction, judgment, operation, human-machine interface, and so on. Generally speaking, SIP research in cooperative areas, for example, dynamic map, cybersecurity, and HMI. This slide shows overview of second phase of SIP ADAS. The operational domain of automated driving will be extended from highway to general public roads, and automated driving system will be implemented in mobility service, including public transport and logistic operations. This slide shows deployment milestone of second phase of SIP ADAS. Stakeholders of commercialization participate in the R&D phase, and mobility service will be commercialized smoothly as the competition on project. Especially investment and business planned by private operators will be promoted by taking full advantage of the Olympic and Paralympic Games Tokyo 2020 and conducting FOTs based on the plans of business and local government. FOTs will start in autumn 2019, about October, in the Tokyo waterfront city area. It includes general roads and Metropolitan Expressway in Tokyo waterfront city area and Haneda area, towards the Olympic and Paralympic Games Tokyo 2022, in cooperation with Japan Automobile Manufacturers Association. R&D in cooperative area will be promoted to achieve early implementation of automated driving. Efforts will also be made to increase public acceptance by involving local government, the general public, etc. There are a lot of field operational tests in Japan. So METI have a foresight for last mile mobility tests by METI. Wajima City, Eheiji Town, Hitachi City, Chatham Town. Before 2018, demonstration tests were centered on technical evaluation of automated driving vehicle system. After 2018, demonstration tests are aimed mainly at AD commercialization possibility for business operators. We think principal factors for determining AD business feasibility, such as profitability model, such as income from passengers and other beneficiaries and prospective public subsidies, and cost cuts in vehicle, roadside equipment, etc. In fiscal year 2018, we strengthened automated driving functions and then conduct the following field operational test. Extend the demonstration period to a maximum of about 1 month by local operators. Demonstration experiment were on one remote operator operates 2 vehicles. In fiscal year 2019, we tried to extend the demonstration period to half year by local government, local operators. This slide shows overview of AD small electric cars. Before demonstration test, we installed electromagnetic wire under road. AD small electric cars can detect electromagnetic. We can use the card in snowy area and indoors. This slide shows 1 month test at AH Town. Electromagnetic induct odd steering and roadside RFID control speed and stoppage. This car max speed is 20 km per hour or less, but in this test, automatic driving speed is about 12 km per hour. I have some photos. This photo shows a lot of elderly people right in this car. This photo shows elementary school students try to ride this car. Mr. Iwasaki, I'm very thank you, visited Mayor of AH Town and rode the AD card. I have a message from Hisamitsu Kawai, Mayor of AH Town. In AH Town, the declining birth rate and increasing elderly population we are facing social problems such as shortage of driver and transporting of elderly people and children. In order to solve the problem, we will make efforts for new mobility service. Regarding automated driving, we have been demonstrating aiming at practical application at the early stage. Mr. Iwasaki visited our town and rode the car last November. Thank you for visiting our demonstration site. We continue to work on mobility service, including automated driving, and hope to announce the AH model to the world. We have planned a half-year demonstration test at AH Town from June to November. If you visit Japan, please contact us. This is the last slide for FOT for autonomous taxi. FOT for autonomous taxi is the taxi to drive on public road in central Tokyo last summer. 5.3 kilometer route starting near Tokyo Station and ending in the Roppongi Entertainment District. The trip cost is 1,500 yen, about $13.5 US one way. The FOT is partly financed by Tokyo Metropolitan Government. The last thing I'd like to say is government of Japan will actualize the automated driving system quickly into society. I'd like to thank you for your attention.
All right, our last speaker, and by the way, I didn't realize my hair was so gray. That was unbelievable. Thank you for taking that. I'm gonna have to do something about that. So our last speaker of this panel is Divi Cambodge. Please come up. He's from Canada. He's from Ottawa. He says it's very cold in Ottawa. So if you want snow testing, go to Ottawa.
Some of the things that we're working on, and it's great to learn that there's so much exciting stuff happening all around the world, and all that, I was sitting over there and I'm thinking, we have to do all of this and do this in snow. So I think that's a unique challenge. So Ottawa is a tech hub and quite underrated, I would say, because I believe in 2018 or 2017, 1 in 4 or 1 in 5 is an engineer or is related to the STEM field. So there's a lot of technical talent in the city. The type of companies that are anchored in the area, in the region, they provide a lot of opportunities in the technology sector, and there's tremendous growth opportunity for the region as a whole. And to cater to the entire autonomous vehicle ecosystem, it's not just the car manufacturer, the OEMs who are the stakeholders in this arena. There are also companies who are creating the software, who are creating the sensor systems, who are providing platforms to conduct these testing, some subsystem level testing, and then integrated overall system level testing. And Ottawa is unique in that regard because they do have we do have companies who excel in those specific areas, and some of them are listed over here. There's R&D, which is coming from post-secondary institutions. We are collaborating with them. There's safety and security, utmost importance, software and data, sensors, manufacturing and integration design and everything. And connectivity, I think, is a key component, and that will be the focus of the majority of my presentation, because the collaboration that we have done with the key industry players in that region are very important to the advancement of autonomous vehicles in Ottawa and in Canada in general. So Invest Ottawa is part of the provincial program called Autonomous Vehicle Innovation Network program. And as part of that program, we are working with both industry partners and post-secondary institutions and the municipal authorities and the local government agencies. We have 5 partners in total which form the consortium. We have Nokia, BlackBerry QNX, Ericsson, Juniper, Invest Ottawa, and we work very closely with the City of Ottawa and the National Capital Commission. Without their help and support, none of this would be possible, because they are helping us create those use cases both in the private and the public test environment. And then, like I mentioned, we collaborate with post-secondary institutions. They provide a good platform to conduct research and simulation-based work, and a lot of their core R&D projects are also integrated into the test beds that we are currently developing. Some of the other companies that have shown interest in working with us, they come from different verticals. We have sensor manufacturers, we have GPS systems, DSRC units, and then Arrigo is a popular name in the autonomous shuttles. So we are coming together and trying to create a very comprehensive testbed environment so that we can capture multiple use cases. So like I mentioned, it's one thing to drive autonomous vehicle in sunny California, but then it's a different ball game when you do it crossing that northern border in Canada. And that's a challenge, because the vehicles need to be equipped to not just detect the road infrastructure and different things that are happening around the vehicle, but also adapt to such conditions where you can't necessarily see the lane markings. There's a lot of blind spots that will arise due to that. And to that point, this slide essentially shows detecting those hidden objects, and you need to be able to provide enough infrastructure resources both inside the vehicle and on the road network itself to actually conduct a safe testing and validation for these autonomous vehicles. We've heard a lot about different standards that are coming up. There's definitely cellular is a big piece of it, and we also have DSRC systems. But what is the next stage? And 5G, we have heard a lot of development on the 5G front. Companies are coming up with their solutions. And I would like to point out that Ottawa particularly stands unique because much of the R&D, much of the development happens in Ottawa with companies like Ericsson, Nokia, Juniper, contributing in that landscape, and essentially promoting the entire V2X infrastructure and V2X adoption for autonomous vehicles. This was October 2017. Ottawa became the first municipality to have autonomous vehicle communicate directly with the public road infrastructure via DSRC. So that's quite a headline for us. And now I would like to share some of the developments that we have done on the testbed front. And Ottawa L5 is the entity, or call it the umbrella, under which we have 2 testbeds, public and private. The intent is that once you are able to validate your products, your solutions, autonomous vehicles in a private setting, then you roll it out onto the public network. The public network, it's 9 kilometers of paved public roads. The traffic intersections are all fitted up with DSRC systems, cameras and sensors. I'll show that a little bit later. There's GPS, high precision GPS, which will give us, close to 2 centimeter precision on your position accuracy, and also the V2X side of things, where you provide 4G and 5G capabilities in this region. And particularly for the public testbed, Ericsson is providing us the 5G network, and Juniper is giving us the 4G LTE, advanced 4G for that. One example of one of those intersections is this slide, where you have multiple sensor devices, and perhaps I'll start from top left, the City IQ sensor nodes. This is by GE. And this is essentially like multiple sensors in a box. We have temperature, humidity, pressure, accelerometer, gunshot detection, so that you have acoustic sensors. So there are multiple use cases that can come out of that. On top of it, you will have a software layer which will provide those different analytical capabilities based on what use case you have in mind. We also have a weather station capability at the intersection, so you have a wind sensor. One which is, I think, one sensor type which is quite unique is the road pavement monitoring. And this one is very applicable to our environment, where the black ice formation can be accurately predicted, and that data can be communicated to the vehicles so that they can act appropriately and respond in the right manner. So you have multiple road sensors in a vicinity. Those are communicating to the central gateway unit, and the gateway unit is broadcasting the data to the car as well as to the cloud platform. The DSRC units as well at these intersections. And some of the early use cases that have come up, this company, we work with, they're called SMATs. What they're doing is essentially RF signature detection. And the intent is that you have multiple units across a certain region, and you have collected a week worth of data, and then you can predict traffic flows, and that data can be used by city authorities, traffic authorities, to optimize traffic light operations. So that's one of the first use cases that we've implemented. So on the private testbed side, this is a bird's eye view of our facility. Overall, 1,866 acres of land, completely fenced and gated. And as a starting point, we are working on a suburban zone. That's phase 1. And the intent is to replicate the same environment that we have in the public testbed and do it in a private setting. So that highlighted area that you saw previously, it's a zoomed-in version of that. We have a 4-way traffic intersection, 3-way traffic intersection, 1-way bike lane, stop signs all around, speed bump, there's pedestrian crossing, there's a parking area where vehicles can practice parking in different permutation combinations of that. So that's a typical suburban setting where an autonomous car needs to validate how capable it is and how effective it is. And deep diving a little bit on the technical front, you saw similar sensors on the public testbed. You have the road temperature sensor, City IQ node, wind sensor, DSRC units. I think one thing which is unique for the private testbed is we are providing a secondary interface unit, a cabinet unit, where companies can come in and integrate their sensor devices. So we provide network and power so that it's easy for them to plug and play different hardware equipment and perform testing. So I think that's unique. And that unit is the the box is connected all the way to the IT server room inside that building that you see over there, and that's all via fiber. And the data is collected and transported to the cloud platform where you can perform a variety of analytical things on top. So, and this is, I think at this site, one of the biggest challenge for us was to provide all these capabilities, but do it in a very agnostic fashion, because the types of sensors, the manufacturers are, the variety of manufacturers that are coming in, and they have different protocols. How do you integrate all that? So I think that's a challenge in its own, and with their technical inputs and engineering support, we're able to do that. One thing which I'll point out is we have a communication tower on site, and at the private testbed, Nokia is providing all the V2X and communication infrastructure. And so we have 4G and 5G capability on site as well as the high-precision GPS systems. This is probably a little bit medium to long-term vision. And so you have the private test facility, but we also have additional 3,000 acres of land, which we are planning to develop further for high-speed testing, merge lanes, et cetera. And currently, we have a designated drone testing zone. Companies and even university students and professors are coming up with their own drone applications and performing testing at this site. So it's quite active right now, and I would like to mention QNX BlackBerry. They're a big collaborator on this front because they have their own fleet of vehicles, which they use on a frequent basis at the site, to conduct testing. So we are ready for testing, and these are some of the pictures over the past few months. That one is Justin Trudeau. This was, I think, back in October 2017 when we did the official launch in the public testbed. That little vehicle over there, right above Mr. Trudeau, is a company. They operate in the military application space, so it's a lead-follow scenario. They're actually an anchor resident on site, so they are actively using the facilities right now and providing these solutions to various defense applications. And I think I saw in one of the presenters' slide deck, Arrigo. So we are partnered with Arrigo. They're a close collaborator with us. As we speak, we have 2 units coming in from UK, at our sites. And I think what's key for us is to understand the capabilities of these solutions that are operating all around the world. How do we actually make them adaptable to a Canadian environment? So all-season operability is a key consideration for that. And most of the systems that we have seen and sensor devices and equipment, they have a limited operating range for temperature, for example. So it'll only work, let's say, -5 to 40 degrees Celsius. But then that's a subset of what we operate in. It's -40 to +40 for us. So we need to validate those extreme conditions and make sure that the systems operate at an optimum level. So some of the branding things that we have done with the Arrigo pods here. And so some of the initial use cases for the pod application is we are collaborating with the Ottawa Airport to come up with a first mile, last mile shuttle for their employees from the parking lot to the terminal, and partnering with other companies who will assist in defining that track and how we can create or integrate multiple sensor platforms to assist in that entire maneuvering of the autonomous pod. And so that's a, I think, pretty exciting effort that's going on right now. We're defining that final use case and creating the 3D maps using SD maps using Baidu Apollo platform. So I think that's currently in progress, and this will be one of its kind application in Canada. And some of the capabilities on the pod front, maximum incline 12%. That's the gradient it can operate on. But then when you have snow, you need to be able, to modify that and make sure that it can withstand those real life conditions. But in terms of upgrading the pods, we would also like to integrate, let's say, infrared detection capabilities in addition to LiDAR and radar and some of the other sensors to make it weatherproof and to make it fit to operate in the Canadian weather. And with that, I would like to thank you for your time, and please visit us at ottawa5.com, and have a good day.
Andreas, Rita. Okay, we only have about 5 minutes for questions, so we're going to get right down to questions. Does anybody have a question? Yes, Carlin? Yeah,
Oh, thank you. I'm used to having to talk loudly, but this will help. So I'm fascinated by all the presentations, but in particular, the one that we just saw in Ottawa. How in the world is all of that funded?
So the provincial government program, the AVIN program I mentioned, we have $5 million for that program, and that lasts until March 2022. And until that time, we have to come up with a sustainable revenue model, and we're working with the industry partners to create that. And in addition to that $5 million, there's matching contribution from all the core AVIN partners, and they're, whether it's in-kind or equipment donation, whatever it can be. So we're all coming together and trying to, chip in and trying to advance and mature the different things that we're trying to do at the test beds. So.
It's a great question. Maybe we go a little bit further. So IDIATA is a privately run, kind of started out as a university research program, correct? Mm-hmm. But now it's privately funded. But maybe more, you don't get any. You get a little government subsidies on your test bed? None whatsoever. So it's all your customers, your clients. They pay for the facility, correct?
Yeah. So yeah, as you said, IDIATA started. We operate a test facility for general vehicle development, including ADAS and automated driving. We started as a university spin-off. There was a major investment from the regional government to build the site. At the end, the civil works is probably the major cost that you might have. But since the very beginning, it was stated that IDIATA had to become an independent company from the government and be profitable. And there was given a 10 years time span to shift from a government-owned company till become an independent company from the government. And we still survive.
My question would be to Japan for the Olympics. You're going to move a multitude of people, or you're just going to have a certain section that's going to move people? Because I can assure you, the Olympics, you will have attention.
I think we have. I think it is not decide, but for Olympic game we prepare some electric cars or some special vehicle. But generally speaking, in Olympic games we can't test. We can't big test because this test make a traffic jam. So I think usually in Olympic Games moving we use general traffic transport system.
Yeah, so they're going to try to use the majority of the normal ways of moving people, but I know the Prime Minister has asked for some of the trips to be autonomous. That's the reason why Medi's focused in on self-driving vehicles.
Yes.
Yep. How much money do you get from the Japanese government?
Probably 3 million
3 million yen?
3 billion yen.
3 billion. So it's about 100 yen per per dollar.
Yes, yes.
Yeah, so just knock a zero off. So they get way more than we do. Okay, we have time for one more. Yes, Neil?
So the public acceptance information
that's great.
was very interesting. In the other 3 countries, what is the public acceptance? And what are you doing in terms of media coverage or other ways of getting the public to be accepting what's going on?
That's you.
No, that's them.
Yeah, so
I did mine.
from a European side, as we said, consumer testing is putting the focus on correctly explain to the general public what are the capabilities of automated driving. So there are press releases, there will be much more press releases during this year and on the oncoming years to test vehicles that are already in the market. So not level 4, level 5 vehicles, but level 2, level 3 vehicles. And not emphasize the performance of the vehicle, but more explain the limitations and how they are correctly intended to be used. Because there is this risk that you as an individual, you expect more from technology than the one you will really have in the beginning. And that might cause problems. So this is probably the main focus of Europe for that.
Mm-hmm. Yeah, and I agree. And I think it's also, and to your point, it's managing expectations. And particularly with Ottawa, I've seen that those initial first mile, last mile use cases will validate the overall adaptability factor as well, and how accepting is the general public to that. And so we are demonstrating those use cases, and so the public can actually physically see and understand what's happening behind the scenes and how things operate. So I think it's more about, it's a visibility question as well, how much we're able to present that development, whatever we're working on, to the general public and communicate on that front. And we have dedicated teams who are working on that area as well. So
we think FOT is very good way to improving social acceptance, especially using occasion of Olympic Games. Thank you.
Field operation test, FOT. Anything to add?
Oh, look, I just wanted to say that my team, there's more behavioural scientists and communications people in my team than there are engineers. Obviously, there's a lot of engineers in my partnership, but one of our key roles is to bring the community awareness and understanding and hopefully acceptance along as fast as the technology. So it's really important that we have demonstrations that they can take part in, and that's why the shuttles are a perfect way to do that. And having the motoring clubs very active in that space, they can actually communicate with their members very, very easily, and they're a trusted brand as far as, you know, their members trust them. So yeah, using the right connections.
So we're going on break. Sorry, but we have to. I'm way over time, and we try to deliver everything under budget and ahead of schedule. So on this one I failed, but we're 3.5 minutes or 4 minutes over. So take a break. They'll be here. In fact, stay up here first, and you can come on up and ask your question. And but take a break, and we're gonna have a great keynote speaker, Anusha Ansari. She's here. It's fantastic. So why don't you all take a break for 10 minutes? Thank you. Thank you.
Thank you.